All right. Um, right. So, welcome everybody. Thanks a lot for coming to this presentation today. I understand that it's really late. There is also the final keynote. So, double thank you for spending your time here today. I hope you will enjoy it. So, I'm going to be talking about resilient microservice API with REST and API gateway. And this presentation was formerly known as REST for real, but then with the passing of the time, the content has been amplified, and hopefully should be enjoyable for you guys. Let me introduce myself really quickly. My name is Vincenzo Chianese. I am an Italian software developer, and apart from the horrible photo from the passport, I used to work for API. That was a company building tools for API developers, focusing on the design part of a web API. Then in January 2017, the company was acquired by Oracle, and I stayed there for a while, and once I realized what the roadmap for the product was, I decided to leave the company because it didn't really fit my vision, and I moved from Czech Republic. I was living in Prague. I speak some Czech, and it's not that different from Polish, by the way. And I relocated in Madrid, and now I'm working for Lunch Badger, a small funded company based in San Francisco, on the Express Gateway. That is the first open source API gateway written in JavaScript and running on Node and Chakra. So those are my references. You can write me an email or visit my blog. Follow me on Twitter eventually, so my coworker can actually see that I'm doing this presentation for real. Or if you want to track the development of the gateway itself, the link is there. But I'm going to be talking about that later. Good. Enough with the silly things. Let's jump to the content. And let me start with the challenge first. Probably here in the conference or around the web, reading documents or blog posts, you probably already know about this thing of the microservices thing. So I'm not going to go a lot into details around that. But basically, we can summarize the whole thing saying, we know more now. So over the decades of shipped application in production, thrown errors, PagerDuties, the community is slowly converging to the general idea that monolithic apps are probably not such a great idea, versus this new way of building software that it's more like, you know what, if we can break up our system into a set of smaller pieces, then I can evergreen those into a set of microservices that are decoupled and, more importantly, isolated, based on business requirements or your boss telling something in particular, or even for technological questions. Probably another framework, another language makes way more sense to be the particular part of your system than the general language that you use. And this is nothing really new, by the way. What's old is new, what is new is old. And it's nothing more than culminating decades of best practices in the modern web coming from big companies such as Amazon, Google, and Netflix. They faced this problem years before us. And although we don't have necessarily the same scale, we can still benefit from this new way of building the software. And also, let's face it, the cloud native technology make this thing extremely easy, because today if you want to spin up a new microservice, you spin up a new container, you give it to your orchestrator, can be Kubernetes or Mesos, Docker Swarm, and it's going to figure it out the things for you. But on the other hand, 5 or 10 years ago, if you wanted to spin up a separate service, you had to speak with your ops guy that had to configure the Apache configuration file or IES or Nginx. And if you were changing the servers, you had to carry on your configuration with you. And on the other hand, today, the server configuration now, it's kind of part of the source code itself, because the Docker file or the Docker compose file, it's part of your repository. So that's one other reason why now microservices are affordable for almost everybody here. Despite all, even if you're moving from a monolith application to a microservice-based architecture, you still keep asking yourself, what is the end game of your microservice? Why am I doing the things in a microservice way? And regardless of that, at the end of the day, the idea behind your system is to expose an interface to a uniform API. And that's something that it's kind of hard, because, for example, if you have a service written in JavaScript and another one in Go or in Java, people tend to expose an API that it's Java-friendly and it's JavaScript-friendly, for example. And this can cause collision and inconsistency and so on and so forth. While even if you're going with microservices, keep in mind that you should reach the end client. That means I don't even know what the client is gonna be. Maybe it's gonna be mobile, maybe it's gonna be a Angular application or an IoT. But again, the way you consume and you use the API should be the same. But this is difficult because microservices are not a specification. There is no a formal document that is describing the way to do a microservice. It's a suggestion, to put it that way. And I want to emphasize this in particular, making a real-world example that I'm showing you in this slide. You can see here we have 3 churches, and I can tell you in advance, those are Gothic churches, well, churches illustrations, for a number of reasons. The first one is that all of them have this big central window that it's way more important than the other ones. But the church on the right has a lot of towers on top of it. This other one has a particular roof color that it's distinguished between the other parts of the building. Those 2 have 2 towers on the top. And you can see that although all those churches are different, they all belong to the same architectural style. That is Gothic. And again, it's almost the same thing, because you don't have a specification of a Gothic church style, but you can recognize a series of patterns that are shared, partially shared, among multiple buildings. And the same way goes with the microservices. You don't have a specification, so there is no way to say this is a good microservice, this is not a good microservice, because, again, they share common things, but you don't really have a real specification. Nobody's telling me that this church should be 10 meters tall, or it should have 20 towers. Nobody's telling me that. It's just about having a lot of towers, and you will have to figure it out, how many of them. That's why it's causing confusion. It's causing a lot of confusion. And the same, again, goes with microservices. There are too many ways to slice and dice on microservices based on what you have and what you want to achieve. For example, you can define microservices based on business capabilities. Like you have a microservice that is handling selling cars, and another one that is handling selling glasses. You can make it them by domain subdomains, user microservice, and billing microservice. And you can also go by model. So you start from your data, you try to figure out how to interact with the data, and then you go with the microservice architecture in your mind. And again, also deployment units. How many services I want to put on an host, and what services I'm going to put on each single host. And that depends also on the legacy you have, or the particular scale you want to have. And if you are at least thinking about those problems when you're coming with your system, you're definitely on the right path. You're asking the right questions. So to summarize this first part is that, microservices, most of the people here, well, most of the people in general think that microservices is a way to reduce the complexity of the system because they are isolated, the code that I have to write and maintain is less, but it's not really true. You kind of removing the complexity from the code, but you're moving it to the network layer, because if multiple requests spawning on multiple microservices, how do you propagate the errors correctly if one of those during the chain is failing? Or also, how do you handle authentication on multiple microservices spread across your system? And the list goes on. But I want to focus in particular on 2 problems that are probably the most basic one if you're going into this world. The first one is the duplication of the code among the services. And the second one is that you are propagating the server implementation detail into the clients in a way that is breaking the client because you're doing the microservices. And we should not do that. And we're going to solve those things. But just keep in mind that microservices has a lot of more problems, a total new set of problems that you should keep in mind, but we don't really have the time to discuss those. So in order to see those things live, we're going to jump to a live example. It should be super simple. So what I do have here, it's the typical customer invoice application. So it's a web server, it's serving a web API, and it lets me create customer, query customer, create new invoices, couple it to a customer, and query those one. So let's have a look to the code really, really quickly. Hopefully you're familiar with JavaScript, but that's not really the point. So I'm defining 2 models. customer with a name and surname, and an invoice model with the date, amount, and the reference to the customer. And then based on those data, I'm defining a couple of endpoints. The first one is to get a customer by ID, or get all of them. Then a post to create a new customer, how to get invoices coupled to a customer over here, and the last one, create a new invoice on the customer that I'm gonna tell you. And given that I want these resources to be protected, I'm using a simple middleware that is checking that all web HTTP requests have an API key, and based on the value of the API key, I mean, this is just an example, so we're gonna stick with simple values. Based on the API key, I'm gonna assign you a role, and based on this role, I'm gonna let you do an operation or not. So if you want to query a customer, as long as you're a user, it's fine. But if you want to create a new customer, you have to be an admin. And same goes with invoices. Wanna query invoice? Fine, user is okay. If you want to create an invoice, you have to be an admin. And on the other hand, I have a super simple client, and again, it's using the WebAPI to let me work with this application. So we're gonna use this thing live right now, just to show you that it's working correctly. I'm gonna spin up the Docker Compose with all the system and the database, and all those kind of details. And let's try to use this client. I'm gonna use the user key so I can, very nice. I think I should probably. Let's try again. Yeah, seems to be okay now, hopefully. Oh, here we are. So when I click list the customer, I can see the list of the customer. But given that I use the user key, if I try to create a new customer, it's gonna tell me, hey, you can't do that. Can you see that here? Unauthorized. Oh, let me see if I can. But if I use the admin key, then I can create a new customer. And it's working correctly. I can list invoices, and I can create new invoices. I mean, pretty simple. Put an invoice date and an amount. All right, super simple. This is gonna be our baseline for the application. So let's say this application is working correctly and has been done for ages, and then if your boss is coming to you and it's telling you, hey, you know what, we're gonna split this application into 2 microservices because it makes sense. You reasoned about it on a table, and you want to divide this thing into 2 microservices for a reason that we don't really know. Let's try to do this thing live. So I do have this other file that is simply empty. So let's split this thing into 2 microservices. So I'm gonna simply copy this part over here. And then, given that I want to split customer and invoices, I'm gonna move the invoice model in the invoice service. Then, of course, I'm gonna connect to the same database, but this is just happening. I mean, I could absolutely use a different database for a different microservice, but in this case, it's easier to share it. And then all the things that are about invoices, like this endpoint and also this endpoint, I can simply move those one here. Of course, I still want the resources to be protected and authenticated, so I'm gonna copy the whole authentication and authorization part. Copy here, and paste it here. And so the new thing, I mean, this thing will be listening to customers.apitest.lan/81, and this other one is gonna be on invoices apitest.lan81. Pretty simple. And given the URL space here, customer.apitest.lan, it's a customer microservice. So I don't really need to say in the URL space, customer endpoint. I mean, it's already in the basic URL. So I can do simply customer.apitest.lan by ID. and create a new one directly. So I can remove this one here. And same goes here. I am on an invoice microservice. I can remove this out of the URL. No big deal. Last thing, given that I am on a different service, I don't have access to the customer model directly from here, so I need to use the web API that the customer service is offering me. So what I should do, I should probably require an HTTP client, and then using the HTTP client, instead of checking that the customer is existing by myself, I would probably do axios.get with customer.apitest.lan with URL and the data and the details. So let's switch to a branch which is ready to use so we don't get in any trouble, because things happen. But it's exactly what I did here. So this is exactly the same code, and just sure to be working correctly. And you can see here that I'm using the HTTP client, using the new web API to get the data. So now, I do have a couple of things opening here. If I try to restart my system, and I would try to use the client, it doesn't work anymore. And it's not because I made a wrong typing in the key, but because the client is coupled with the server to look for a particular URL. And now that I move it into a microservice way, the URL space changed. So my reorganization in my system had consequences in the client that doesn't really care where your services are, but still it got affected and it totally broke. So I should modify the client, redeploy the client, and every time I'm making those kind of big changes in my microservice architecture, you may be spinning up multiple microservices for just a couple of days and then shutting them off. You can't really afford to redeploy the client every single time, right? So we need to find another way. And another thing that you probably noticed here is that I had to copy-paste authentication and authorization part. And now here it's easy, because this is both of the services are JavaScript applications. They're using the same framework, connecting to the same database. So it's easy. It's a copy and a paste. But if you imagine that one service is JavaScript, another one is Java, and another one is Go, then it's not copy-paste anymore. It's a new implementation, and you have to hope that they are behaving in the same way, or you will get into inconsistencies. So you're sharing code that you're copy-pasting code that could be shared, and you need somebody at the beginning of your service that can handle all those things for you. So let's try to solve those two problems. And let's start with the duplication of the code that I show you, and then we're gonna also figure it out how not to break the clients during the journey. We can solve the first problem using the API gateway pattern. So I'm gonna explain it really, really quickly. So you have a client, and you have this problem that even if you're not doing microservices in your application, you're still using multiple services. Because if you want to, for example, embed a map in your application, you don't really make the maps for yourself. You use Google Maps. If you want to go with payments, you don't do payments on yourself. You use Stripe or you use Braintree. So you have a lot of public APIs that you should be talking to. And if you're doing microservices also in your organization, you also have your internal APIs. You also have partner-specific APIs. And today, there is this rise of functions as a service that are being spawned everywhere. And in all those ways to communicate with system, you need a way to share the things that are the same across the whole organization. And this thing can be done by an API gateway. That it's simply a piece of software that is being put on the edge of your system, and it can handle the things that you want to care about, like authentication, security, traffic controls, logging, transformation of the request, and a lot of other things. So an API gateway could actually be a good idea to not replicate the authentication code among multiple services. But the API gateway can do way more. So for example, in the example I showed you in the code, we do have a granularity problem, because if I want to show invoices information, I need to query the customer service first, then an order service first, and then an invoices order, an invoices endpoint at the end of the day. And although, I mean, probably it can be performant, but it's a chatty communication, and the client doesn't really want to do all those requests. So an API gateway can offer optimized endpoints, collapse multiple requests into a single one, and offer you a single response with all the data you need. So that's a way we can solve the first problem. Now let's try to think about and solve the second problem, like changing the system, it's breaking my clients. And REST is probably a way to solve this thing. Let's try to run to the spec really quickly, but REST, again, a little bit of story, was a dissertation published around 2000, and by definition, REST is a system that has the following features. It's a stateless system that is layered, has code-on-demand feature, and it's a client server. And it turns out, if you think about it, HTTP is stateless, and you know that because it's stateless by definition. It's layered because if you put proxy during the journey of a web request, the result is still the same. It has code-on-demand feature, that is the JavaScript that you download on your browser. It's a client-server thing, of course, and it also has uniform interface, but we are gonna get to that later. It turns out the REST was the rationale on the deployment of HTTP 1.1. So it was by definition, was on purpose. Unfortunately, still today, the REST definition among the community is still like everything is a resource, that's REST. No, I mean, REST is a set of architectural constraints that I showed you before, and do not be biased by the blog post, but please read the documents, do not get biased. It's a totally different thing. So we have the point that we are still trying to figure it out is the uniform interface. What does it mean having a uniform interface? And it turns out that Roy Fielding was also explaining this part. A uniform interface is an interface that is offering identification on requests. And you have it, because URI, by definition, it's an acronym that stands for Unique Resource Identifier. You should manipulate resources through representation, and we're good with that because HTTP is one of the last protocols that have a content negotiation mechanism built in, intrinsic in it. Self-descriptive messages. We also have this one because you have headers and payloads. You can attach data and metadata. So you do have all the things you need. And the most important one, the hypermedia should be the engine of the application state. And with HTML, we can do that. HTML is an hypermedia format. So let's try to think about the application I showed you a couple of minutes before from a kind of an HTML perspective. So what I will do, I will navigate to my system, and I will get a web page with a set of links. And it's telling me if you want to list the customer, click here. If you want to add a new customer, click here. And the list goes on. And then I click on list customer, and I get a list of customer. And if you want to have customer details, that is your link. And then I click on the first customer, and I got the data. And if you want to see the invoices of your customer, click on the link. So my point is that in this simple example, all I needed to know in order to navigate into the system was the initial URL, that it's going to be probably customer.apitest.lan. But once I'm there, the way I navigate through the system, it's not because it's a shared understanding ahead of the time. I'm discovering the capabilities of the service just following the links. So one of the ideas that people had in mind was, you know what? HTML could actually be the API, could actually be the payload I'm consuming in order to discover your system. But unfortunately, the web pages are not really like this, but are more like those giant things, because we are kind of coupling the graphic details into the HTML. So it's still doable. You can still parse the HTML and try to figure out links and relation on yourself, but it's really, 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 really easy to mess it up. So what we could do, we can port this wonderful idea into a more data-centric representation format, such as JSON. And this thing happened multiple times. There are multiple JSON formats that are hypermedia friendly. The first one that came into the space was al plus JSON. That is nothing more than the JSON payload with supports to resources and links. That is Siren that has got entities, links, and actions by Kevin Weber, and RESTful JSON. And again, it's almost on the same page like HAL plus JSON. So we're gonna use, for this example, the last one, because it's super easy. It has two simple rules that you can, in order to make a payload hypermedia friendly. The first one, if a JSON object has a URL property, it's a link to the resource itself. A JSON object that has a property with the URL suffix is a related link. So what I could do, instead of just returning the data with ID, name, and surname, I could also return the URL and the invoices URL. What I just achieved with such a payload is that beyond the data, I'm also telling to the client, this is where you are, and this is where you can go from here. And this turns out to be extremely powerful. And keep in mind that thinking in the same way the browser thinks into your system, your web APIs, you can still, for example, leverage the history. So you can go back and you can navigate through the system using the URLs. So let's try to modify the system we had here in place that is breaking the client in a way that it doesn't really break that easily. So if I do try to switch, I do have another branch over here, and what I just did, I implemented a simple API root endpoint, and it's telling, you know what, you came here, you are in the API root, and this is what you can do with this service. So you have a list of action, and it's, you can list the customer, you can create customer, you can list invoices, and you can create invoices. And then if I go to my customer service, when here, instead of just returning the payload, the data that the client is waiting for, I'm also telling you, if you want to see the invoices of this customer, this is the link that you should follow. And this is where you are. And in the same way, goes with invoices services. Instead of just returning the invoices, the data, and also telling you, here is where you are, this is how you can go back to the customer. So the client, I do have this new chunk of information, and I should leverage this somehow. So I also modify the client. For example, over here, the list of the action that the client is offering me is no more fixed into the code, but it's being returned from the server. And every time I do an action over here, the URL is not constant into the client anymore, but it's being extracted from the payload. And you can also see here that there is no authentication and authorization part anymore, because I also installed an API gateway that is handling the authentication for me. So in a way or another, if a service is hitting this part of the code, I can say, this user is authenticated and is also authorized, because there is an API gateway that is storing those things in a shared way for me. And this thing has been configured here, by the way. So you can see that when you're hitting the customer API test.lan, it's following a particular action. When you're doing the invoices, it's going to another part. And this is where I'm telling, hey, you need to be an admin, or you need to be a user to perform this operation. In this particular case, all the get operations that are queries requires a user scope. All the post operation that it's creating the data, they do require an admin scope. So pretty simple. So let's shut down what we do have here, and let's start the new system we just created. Okay, it is up. So I'm now using the new client. First, let's try to install the things. Okay, gonna use the API key here, and I should be able, oh, I'm not authorized. Well, okay. I mean, the system is working correctly again, but this time all the operations are not coupled anymore, but the URL that you should follow in order to navigate the system, it's coming from the server. And let's put the things even further. And let's say that you built such a system, and then after 3 months, your boss is coming to you and it's telling, you know what? This microservice idea didn't really work. We need to go back to the monolithic system. So please move the code into a monolithic system again. And in a normal case, this will be a major pain in the ass. But in this case, it's not, because the client doesn't have any specific knowledge on the way the server is organized anymore. So what I just had to do, I just modified the URLs so that also the invoices are served by the same endpoint. The invoice service is now empty. You can see it over here. There is nothing here. And all the 4 endpoints are again served by the original monolithic system. And if I now try to run the client again, I'm gonna use this thing again. Now with the same client, I'm interacting with the monolithic system, and I can interact with a microservice-based system. The client doesn't break because the client doesn't even know what the system looks like, because the system is telling, this is the way you interact with me. Follow the links and do not make any kind of shared understanding ahead of the time that you have to put in your code and stick with it forever and ever. And with this kind of part, this simple layer of indirection can give you a huge amount of possibilities. For example, just telling a couple of those, let's say that you are going under maintenance and you can't offer invoices service to anybody. You just remove those 2 links, and our client will not show those options because the client doesn't even know that this option is something that you can do. Or also, if you go here, if we can move the things even further, simply, if you don't have access to the invoices endpoint, I can simply not serve it at all. And the client doesn't even know that I can explore the invoices of the system because there is no knowledge about that anymore. So that's really a really powerful way when you have a lot of microservices that are spinning up and killed on daily basis. You cannot afford to redeploy the clients every single time. You need a way to communicate the knowledge, putting the understanding into the runtime and not sharing ahead of the time. That it's killing you. So, couple of words on the API gateway. That is the basic technology that is powering this thing. Again, no matter what kind of style of microservices you are employing, you need a super glue. Authentication, authorization, logging, rate limiting, and all those kind of stuff must be shared among the whole system you have. And we decided to build one open source using Express as a baseline because, first of all, the barrier to enter into API gateway today is still high. You have Kong, you have Thick, but those are programmed in Lua or other languages that are absolutely performant, but the barrier to enter is high. On the other hand, if you touch at JavaScript at least once in your time, you're probably familiar with Express. And it actually is fitting the use case perfectly. The API gateway we built offers several features and benefits. We are actively working on it. It offers authentication, authorization, CORS, JSON Web Token support, dynamic routing, so on and so forth. And what we did, we just took Express and we supercharged it with a dynamic pipeline system based on parameters. And you can define pipelines with a list of policy, and when a request is coming in, we are evaluating the pipelines and the policies you're giving to us, and if conditions holds true, we're gonna execute an action that you say to us. And authentication is just one of those, and then you can proxy the things into your internal service. And then of course the request goes back but you can transform the request, removing the payload, or you can transform the response to keep compatibility, or even to strip out the payload if the data you're getting is really chatty and kind of useless for your client. So to wrap it up, if you're interested in this thing, installing the Express Gateway, it's that simple. One command away and you're good to go. And one last thing, I mean, for small communities like the one we are doing, it's really important to see the adoption. So we will really appreciate if you would have a look into and give the feedback, if that's useful, if it's not. And as I stated at the beginning of the talk, microservices is not just about those two issues, but there is way more problems that you might have during the journey. And we are trying to solve this thing with the company we founded, where we do try to solve the whole microservice pain in the ass that sometime you might end up. Again, if you're interested, those are all the references, and that's basically the whole idea I wanted to share with you, and I'll be happy to answer any question if you have any. Thank you, guys.